Hello, my name is Zawad, and I'm the head of electronics in the Cyborgs. Welcome to our first lesson on basic circuits and electricity. If you have any further questions, feel free to contact me at munshi@bxscience.edu. Let's get started. A circuit is a closed loop of electrons. Electrons will want to flow from where there's a lot of electrons to where there aren't a lot. We can take advantage of this movement and energy by putting something in between, such as a light, and convert it to a different type of energy. In this little schematic you see below, the battery might have a positive end with a lot of electrons and a negative end without a lot of electrons. So the electrons will flow through the wire through an LED and then go back into the negative end. We can use this flow of electrons to go through the LED and power the LED. So we can convert that movement energy to, kinetic energy, to a light. So the three basic units of all circuits are voltage, current, and resistance. Right now, I'm just going to go over the scientific definition of all these concepts. Don't worry if you don't quite understand it just yet. I'll explain it more later on. Voltage is defined as the electric potential difference and is measured in voltage. It's identical to the idea of potential energy when you're about to drop something, for example. There's a long distance for it to move and drop, hence that's kinetic energy. Voltage works the same way. We can use this quote-unquote kinetic energy through a wire to power stuff. Current or amperage is defined as a net rate flow of electric charge and is measured in amps. Essentially, it's how much electricity you can pass through at a time. Resistance is the opposition to current and is measured in ohms. Generally, anything you power, such as your phone, refrigerator, or computer, has resistance to it, as it uses the electricity that passes by to perform its functions. I like to use the water analogy when I think of these concepts. It makes it a lot easier to understand. Voltage is the pressure of the water, or how fast the electrons are moving through the wires. Current is like the size of the pipe, so how much water you can push through at a time. Using the analogy, this means how many electrons you can push through at the same time. As you can imagine, having a lot of pressure, voltage, and big pipes, current, you have a lot of water going through at once. Or in the case of circuits, a lot of electricity. Resistance is like having sand in the water. Having more stuff blocking how much water you can pass through means that there's less water going through at the same time. The same applies to electricity. If you have more resistance, that means less current, and in the end, less electricity going through. That brings me nicely to my next point, which is Ohm's law, and this basically describes the relationship between voltage, current, and resistance. Generally, voltage is going to be pretty constant. You're going to have one power supply that supplies a constant amount of voltage, whether that be 120 volts from the wall or 9-volt battery, stuff like that, right? So you're going to be working with mostly current and resistance. So if you have any of these two quantities, so if you have voltage, current, and resistance, if you have any two, you'll be able to calculate the third one. If we go back to the water analogy, that makes perfect sense, because if you think about it, the more resistance you have, the smaller the size of the hose, because you have more sand, less area to go through, which means you have less current. But the pressure is always going to be the same, because the speed of the water is always going to be the same. Even if there's more resistance, so there's less space to go through, the speed of the water isn't going to change. The pressure is going to stay the same. It's just there can be less water going through at the same time. So let's start to build a basic circuit on Tinkercad. So Tinkercad is basically a website that lets us design some basic circuits. It's just easier to show on a screen, so we're going to use this for now. A breadboard is a way to test circuits before we do something permanent. So a permanent circuit might be a circuit board, or like if you take apart a computer, you'll see small circuit boards everywhere, right? You're not going to see breadboards in an actual product, but it's a good way to prototype circuits and just like design something before we actually put it into something permanent. So something that confused me at first was just how the rails are connected. So the positive rail these are all connected. So everything in a positive rail is connected here. So generally everything here would be connected to a power supply, which let's just put one in right now, right? This is a 9-volt battery, and you put a negative end here, and a positive end here. So everything here is connected to the negative end to the battery. So this goes through ground or negative, and this is connected to the positive end of the battery. So all of this is connected to the battery rail. This is separated from all of this. Every column in here is connected to each other. So everything in column 1 is connected, everything in column 2 is connected, everything in column 3 is connected, etc. Right? But everything from F, G, H, these are separated. So each row is separated from each other row. We can use this to create a circuit. And also remember that this side of the breadboard is separated from this side of the breadboard. Unless you specifically bridge them like this, we're going to just work on one side of the breadboard. We're building a basic circuit today, so we don't really need to worry about that, but that's just good to know. We're going to put in a LED here. This is a anode, and the longer pin of the LED is the anode. So that connects to a positive end. We want electrons from going from the battery positive through end here to the long side of the LED through the LED, right? So how do we finish the circuit? We need to complete a circuit, otherwise electricity will not flow. So what we could do is go from the negative end. So everything here is connected, goes from the negative end to the negative end here. And then that connects the circuit, positive here, through the LED, through here, and then goes down, right? If you try that, that's gonna blow up the LED. This is because LEDs are very weak. They have a very low resistance, which means you can only put so much electricity through it before it just can't handle it anymore. We can limit the amount of current that the LED can handle, well, receive, if we use a resistor. So this is a resistor. We can use this, so I'm just gonna get rid of this wire real quick. You can put this here, connect it from here to here. So now we have, this is a 1K ohm resistor. So if we want to calculate how much current is going to this LED exactly, it's 9 millivolts. How do we know how much current an LED can handle before it bursts? Well, most of these LEDs have specifications on them, so you'll usually look it up, or like it'll give you information when you buy them how much current they can handle. This depends on the manufacturing process and the color of the LED. It matters on a lot, but in this case, we know that 9 milliamps should be plenty for this LED to turn on and should definitely not blow it up. So this circuit should be complete. So we have positive going through here, going to the LED through here, and then going down into the resistor, back into negative. We start the simulation. Lo and behold, our LED turns on. That's just the first the first circuit we'll make. That's the very basic. If you've done programming, it's a hello world of circuits. But that concludes our first lesson. There's a lot more to do, a lot more to explore, and we're going to go into a lot more in the near future. But I hope you enjoyed this lesson, and we're going to sign off for now. Bye.